Two-dimensional plane can be divided into two sides, the top side and the bottom side. If an ant is on one side, it must cross the boundary to reach the other side. But is it possible for the ant to reach the other side without crossing the boundary? The solution is to turn the plane into a long strip, align the two ends, twist it by half a turn, and then connect them. This forms the famous Mobius strip. On this strip, the ant can travel infinitely in a loop and reach the other side without crossing any boundaries. Technically, the top and bottom are actually on the same surface, as the originally parallel edges of the plane have been merged into one continuous loop. If we cut the strip in the middle, bend it, twist it by half a turn, and reconnect the ends, it remains a continuous Mobius strip. Even after cutting it open, the strip still functions as a single continuous surface, allowing the ant to seamlessly move between both sides. Now consider a holosphere. It is formed from a two-dimensional surface shaped into a sphere. The holosphere has two sides, one on the outside and one sealed on the inside. So how could an ant on the outside cross this closed loop and enter the inside of the sphere? At first glance, this seems impossible. However, the famous Klein bottle offers a solution. If the ant follows the surface of the Klein bottle, it can enter the inside without crossing any boundary. This is because the Klein bottle connects its inner and outer surfaces into one continuous surface, effectively erasing the boundary between them. Technically, the Klein bottle is a four-dimensional object, but the human brain is accustomed to perceiving the world in three dimensions. Our understanding is limited to three dimensions: one-dimensional, lines, or closed loops formed by lines; two-dimensional, planes, surfaces, or curved surfaces, including hollow models formed by surfaces; three-dimensional, solid objects like spheres, toruses, or polyhedra. When we observe the same object from different dimensions, we reach entirely different conclusions. For example, take this simple shape. At first glance, you might think it's a hexagon made of 6 triangles or 3 intersecting lines within a hexagon, but in reality, it has no connection to a hexagon. It's actually a cube. This demonstrates how observing an object in 2 dimensions versus 3 dimensions can create 2 completely different perceptions for the human brain.